This is just a quick tutorial on R and problem set 5. So in this problem set, I'm going to give you the basics of an R script, but I'm not going to spell out how to write the code on each of the problems. In the previous problem sets, I've given you most of the R code to run the entire problem set. Now I want you to start a little bit more from scratch. I'm giving you some of the R code, but not all of it. So the first thing is you have, for this data or for this problem set, you'll have the house price data, which is data on house prices and the characteristics of houses. So we're going to try to figure out. This is called a hedonic model. We're going to try to figure out how much each of the attributes of a house contributes to the house price. Or like, what is the effect of an additional bedroom on house prices, or how much are people willing to pay for an additional bedroom on average, or an additional bathroom, or moving closer or further away from an interstate, for example. So the first thing you have to do is, of course, import the data, which I will talk about in a moment. But then after you have the data imported, you're going to create a scatter plot. You'll create several scatter plots in this data set, or in this problem set, of housing prices on different variables. You will estimate several different models, regression models with price being your dependent variable. And then you'll have different variables on the right-hand side, square feet in the first one. You'll have a multiple regression in the second thing you'll have to run, so you'll have to add square feet, bedrooms, baths, interstate, and age to the model. Then you'll have to look at the R squareds, interpret the coefficients and their standard errors, their t-stats, p-values, etc. Talk about which model you prefer, comparing the simple model to the one with additional regressors. You also then have to create new variables. So we have, you'll have to add variables to your data set, the log of price here. You may even have to, you'll have to add the squared term of square feet and add it to the model. And then you'll have to get predicted values. So each of this I've done in previous problem sets. So if you have questions about it, go back and look at the R scripts from the previous problem sets. I'll do a couple of examples here, but you can also see how to create variables, how to run different models, how to plot things with the R scripts from the previous problem sets. And then the last bit is we don't use R. Okay, so let's look at what we've got. First thing, when you open the script for homework 5, clear your workspace. Now you get your working directory. So in my case, I've already set the working directory to where I've saved the data. So when you download the data from Canvas, you're going to save it somewhere. Maybe just leave it in your downloads folder. That's probably not the best place to leave it, or to save it, but maybe you have it there. Maybe you have a folder on your desktop that is econometrics or something like that, or maybe you have a Dropbox folder. This is just a note to anybody that's not saving things on Google Drive or Dropbox at this point, or if you're not backing up your data, your papers or whatever, you're going to lose them at some point. Start using Google Drive, start using Dropbox, start using a hard drive that's backing up your stuff. Just at this point, there's no reason not to. Plus, you all get free unlimited storage on Google Drive with your @RAMS account. Okay, so saving your data somewhere. You've downloaded it and you put it into a folder. So let's see where we've put it in on my computer. So I have it in the problem set 5 folder. Now here's where you need to start thinking about paths and directories. So the data isn't going to be able to be loaded, I don't think, just by opening it in R. For some reason, there's a glitch in R that doesn't allow you to do that, and I haven't been able to figure out the workaround other than using, well, the technical thing that's happening is when we load in the data, we use read RDS as a command in the R script, but when you open it by clicking open up here or open over here, it's using the load command, which for some reason does not load data. So we can use the read RDS command, but not the load command. So we have to do this by using this command in our script. The house price is going to be equal to reading in the data house price. So we have to find our working directory or the path to that data. Where did you save it? Did you save it under your bed? Did you save it in your closet? Did you leave it in your car? If you're going to tell somebody where that data is, you have to give them directions to find it. So that's the same as a computer. If you're going to tell R where that data is, you have to tell R where to find it. What folder did you save it in? So on a Mac or on a PC, that's really simple. You open up your folder, and then up here, you just click in this box, and there's your path. You can copy this, Control C, or you just go right click, copy. You can go in here and set working directory, highlight this, and put it in there. Now note that puts in backslashes, and R sees forward slashes. So you do have to go in and change these to forward slashes. I think you can try it with backslashes, but I can't remember if R understands backslashes. I think you have to put in forward slashes. So replace that with forward slashes. Now we can set our working directory, and we can do that anywhere. We can go back out one folder. So now I could set it to the problem sets folder. But then if I told R to go look for the house price data in the problem sets folder, it's not going to find it. It's not going to know to look within the problem set 5 folder of the problem sets folder to find the house price data. It's going to give me an error if I set the wrong path. So I have to open up the path, click there, and then here's the house price data. It's going to find it in here. So I set my path. Now I can run this line of code, and it shows up over here on the right hand side. So now it's here. Now if you have a Mac, it's a little different. I've been looking at how to do this on Macs, and I think you can use, I found a couple different ways to do this. How to find a file path on Mac. Here's one website, and then here's another that I found. 5 ways to reveal the path of a file on Mac operating systems. So this way that they're telling you first, which is the same as this website, is essentially you go to your Finder, you right click on the file, and you go to Get Info. Then that tells you where, but that doesn't really help because you can't cut and paste this as your file path. You need the forward slashes, etc. So how to copy the file path? Go to the Finder, click View in the upper bar, click Show the path bar. That's going to give you the path bar at the bottom of the Finder window. Then you can open or you can right click on a file essentially, or control click the file and then hold the option key, and then in some operating systems that gives you the option of copy as path name in here. Doesn't work on my wife's Mac, so I'm not sure what's going on, but I did get it to work by using this method here. Use Finder to view file paths. So you go to your Finder, you open it up, and then up at the top there's uh, you can click the button Go, and then within there you find Go To folder, and it opens up this little dialog box here for Go To folder. And what you do is you drag and drop a file into there, and it tells you what the path is. So you open this up next to your file, the data, and you drag and drop the data into this little box here, and it'll tell you the path. And then once you see the path with the forward slashes, you can right click it, copy it, and paste it into your R script here. So make sure when you paste it in, it's in quotation marks. That's because this is what's called a string. It's a string of, it's not numbers, it's a string of letters essentially. So R has to see it as a string, and to do that, you paste it in with the quotation marks. Okay, so now once we've set the working directory, we can read in the house price data. We've done that. Then we want to attach it just so R knows that's the data that we want to use. And then we want to plot some variables. So I gave you the basics of the plot command, but I left it pretty much empty. I give you, okay, you want your Y variable here, your X variable here. So let's say for this we want to do house price. We want to do, that's the data set. You know, you don't even need this if you tell R you want to attach the house price. So let's just do, so price, and let's see what other variables we have. We have age. Let's do age. See if we can run that. Yep, it allows us to do that. So we don't have the main as the title, so we could put title here. X label is going to be you know, I have those backwards. The price is the X variable, the age is the Y variable. So price, X label is price, Y label is age. So let's rerun that. Now we get price and age in the title. So you want to change those things. Change the title, change the X label and the Y label so that a reader knows what variables you're plotting. Then let's do a linear regression. So let's regress Y on X here. So I've given you Y and X, but those aren't variables on our data set. So maybe we want to regress price on age using the house data set, house price data set. Run that, and we can summarize the linear model. It says that an additional year of age reduces the house price by $440 with a standard error of 70.1, t-stat of negative 6.285, so that's an absolute value greater than 1.96, so we reject our null hypothesis. P-value is very small. Notice the e to the negative 9. So that's a really small value. One thing that I think probably people haven't noticed yet, if you want to run two different models and keep the results, rather than, so I could run age and I'll have plus, let's throw in beds and square feet. Beds plus square feet. Okay, now let me call this something else. I can call this dogs and cats. Now I'm going to summarize. Rather than linear mod, I'm going to summarize dogs and cats. So the output of this model is now called dogs and cats. There we go. I can summarize that. And great. Now I can have the summary of dogs and cats, and I can have the summary of linear mod. So I can summarize linear mod again, even without rerunning the model. Okay, the other thing you need to do is create new variables. So if I want to add a new column to my model, or to my data set, a new column that is age squared. I might call that variable age2. I'll say I want to add a new variable house to the house price data set, and I'm going to call it age2, which is going to be equal to the variable in the house price data set age squared, or raised to the second power. So run that. Let's look at our data set, and indeed it created age2. So that's just going to be age squared. 48 squared is 2,304. So the most important things here are figuring out your path. This is going to be a challenge for people, I assume, but this is a good thing to do, to know how to do. Remember to attach the data set, and now you can see how to change these lines of code so that you end up running different models, and you can add new variables to your model. And if you want to do predicted values, you can create those predicted values by, in the same way you're adding new variables to model, but we could suppose let's create the predicted values from the linear model here, this first one. So let's create house price. We can call it predicted 1 is equal to, what's our intercept? Our intercept is 104035. I'm getting that from here. 104035. That's our intercept, minus the age coefficient, which is negative 440, times the house price age variable, because that was our variable in the model. So what does that give us? That gives us the predicted values. Let's run that line of code. Here we go. Predicted values. So the real value in the data set is 60,000 here. The predicted value is 82,915. See you in office hours.